Hi everyone, welcome back to this video where I'm going to discuss the second concept which has been given in OSI security architecture, which deals with security services. So let's talk about what are the services that belong to security domain and how they are to be implemented. Okay, so first things first, when I was browsing the internet, I came across two definitions which define the security service. The first one is given by ITUT. As discussed earlier, ITU stands for International Telecommunication Union. It has two branches, ITUT and ITUR, whereas ITUT stands for the Telecommunication Standardization Sector and ITUR stands for the Radio Communication Sector. Their recommendation X.800 defines the security service as a service provided by a layer of communicating open systems which ensures adequate security of the systems or of data transfers, which means to say that the service is actually provided by one of the layers of the systems which are participating in the communication, which will ensure you some kind of protection or some kind of security to the system or of the communication that is taking place. The second definition, which was provided by the RFC 2828, defines the security service as a processing or communication service that is provided by a system to give a specific kind of protection to system resources. This is self-explanatory. It says that the security service is something which you have given. It might be anything, a processing or a communication service, which adds or which provides one kind of or a specific kind of protection to your resources. That is called as a security service. This point is noteworthy. Security services implement the security policies and are implemented by the security mechanisms. A security policy is a document or the ways or it's a list of ways how security can be implemented within an organization. So security services implement security policies and are implemented by the security mechanisms. X.800 divides these services into 5 categories and 14 specific services. You can see this. These are the 5 categories of security services. The first one is authentication, access control, data confidentiality, data integrity, non-repudiation. So these are the 5 categories, and the 14 specific services are peer entity authentication, data origin authentication, connection confidentiality, connectionless confidentiality, selective field confidentiality, traffic flow confidentiality, connection integrity with recovery, connection integrity without recovery, selective field connection integrity, connectionless integrity, selective field connectionless integrity, non-repudiation origin, and non-repudiation destination. So we have the categories and we have the specific services. If you count them, you have 13 here. The 14th is the access control. And also we added another one, which is the availability, which can also be considered as a security service, which we will discuss at the end of this video. First, let us start with the authentication service. So authentication service deals with assuring the identity of the communicating parties and also no third party masquerade as the legitimate parties for unauthorized transmission or reception of messages. There is a lot of things over here. So to make it simpler, let me simply say that. And if let us assume that there are two communicating parties, A, okay, and B. These are the two parties. And if B received a message M from which is supposedly from A, this authentication service will assure B that this message has in fact come from A or not. It will assure that it has been coming from A itself. That is one thing. The second one is when A and B are communicating with one another, assume it's a connection oriented service, this authentication service will also ensure you that A is in fact talking to B and B is in fact talking to A. So it ensures the identity of both the communicating parties. So A is assured of B and B is assured of A. That is what is written over here. And it will also ensure that there is no third party which is masquerading as either A or B. If you remember, masquerading means pretending to be somebody else. If there is some party which is C here and it starts pretending as A and sends a message to B, this is not possible. Authentication service is going to deal with that. So it says that it assures the identity of the communicating parties, and also no third party deals or no third party masquerades as the legitimate party for unauthorized transmission or reception of messages. This is what the authentication service does. Simply put, it assures that the message is indeed from the source which it claims to be. If I am saying that the message has come from A, I have to be assured that this message has in fact come from A or not. There are two specific authentication services which are defined in X.800. The first one being peer entity authentication, which provides corroboration of the identity of a peer entity in an association. In a way, what do you mean by peer? Peers are, we can call the entities which implement the same protocol on different machine for communication purposes are called as peers, peer-to-peer communication, isn't it? So peer entity authentication, the name itself suggests that this service actually proves the identity of the peers with one another, which are participating in an association. If there are two parties which want to communicate, starting from the communication establishment phase till the communication termination phase, this service will ensure that the identities of the parties remain the same, and it will ensure the identities to one another. So this service provides confidence at the time of usage only that an entity is not attempting a masquerade or an unauthorized replay of a previous connection. So if in fact A and B are establishing a communication and they are going to start their transmissions, this service will ensure the identity of A and the identity of B, and it will safeguard against any other party masquerading as A or B. The second service or the second specific service of authentication is called as data origin authentication. Once again, the name itself tells you it provides identity of the origin of the data. So it provides corroboration of the source of a data unit. In a connectionless transfer, it provides assurance that the source of the received data is as claimed. So if this is A, imagine this is A, and it has received a message or an email saying it is from X or Y, then this service has to prove to A that this message has in fact come from Y. If the message has the address of sender is equal to Y, then A has to be assured that this message has come from Y itself, but not from X masquerading as Y. That is called as data origin authentication. Here, there is no specific protection provided against the duplication or modification of data. You are just ensuring that the origin of the data is genuine or not. That's all. So these are the two specific services provided by the authentication service. Let's move on to the next service, which is your data confidentiality service. It is the protection of transmitted data from passive attacks and the protection of traffic flow from analysis. When we were discussing about the security attacks, we spoke about the release of message contents and traffic analysis, which comes under the category of passive attacks, isn't it? So, and passive attacks are these are the attacks which are done on confidentiality. So confidentiality has to ensure that your sensitive data remains private. It is not, there is no unauthorized disclosure to the third parties. Okay. So that is what data confidentiality tells you. So it has to protect your data from third parties, and also it has to protect your data from traffic flow analysis attacks. There are 4 specific confidentiality services which are defined in X.800. First one, connection confidentiality. This provides protection of all user data on a connection-oriented transmission. Earlier, I told you that let us assume that if you have two communicating parties, A and B, if they are going to establish a connection-oriented transmission, maybe using TCP or something of a protocol, then this service will ensure that each and every transmission that is done for this particular communication is encrypted. So it provides protection for all the user data, all the messages that are sent over this particular transmission. For this transmission between A and B, they are protected. That means they are encrypted, so that you are providing confidentiality, the protection of all user data on a connection-oriented transmission, starting from the connection establishment till connection termination. The second service is something called as connectionless confidentiality. This provides protection not to all the user data, but maybe to some data on a particular single data block. So if I want to ensure that, see, I don't want confidentiality for all of my packets or for all of my data blocks, I just have sensitive information in one particular block. So I can apply confidentiality only to this particular block. This is that particular service which conveys this connectionless confidentiality, which provides protection to all the user data in a single data block. So not all the data blocks, not all the messages, but to only one single data. The third one being the selective field confidentiality. If you have studied about TCP and IP, there are a lot of header fields involved. The destination IP address, source IP address, destination MAC address, destination port number, source port number. There are a lot of fields that are placed for every data packet. So this particular service, what it does is it provides confidentiality of the selected fields within the user data on a connection or in a single data block. So if I want to mask, or if I want to mask the sequence numbers or the destination addresses, I can apply this service so that all the packets that are transmitted for this particular communication will have their destination addresses masked or encrypted. In that way, I can actually apply this particular confidentiality service to only selected fields within my packet. These fields might belong to a single data block or all the data blocks. The selective fields can be encrypted for all the data blocks on this communication. It can be done for a single block or for all the packets on this. The fourth one is something called as traffic flow confidentiality. As we discussed earlier, an attacker performing a traffic flow analysis might be able to gather enough information to be able to guess the identities of the source, origin, the location of the source, location of the origin, length of the messages, frequency of the messages, type of the messages. So there is a lot of information which can be gathered by an attacker by performing this traffic flow analysis attack. So this service, what it does is it will provide protection against the traffic flow analysis. Maybe it will mask these addresses, mask the length of the message, or it might add some kind of padding to your messages so that the length remains the same. Like those kind of things can be done here. Ultimately, it ensures that your transmission is protected against the information that can be derived by the attacker using a traffic flow analysis attack. So these are the four specific services that comes under the confidentiality service. So ultimately, what we are trying to see is that you provide protection against passive attacks and protection against unauthorized disclosure of your sensitive information to third parties. That is what we are trying to do under confidentiality service. Let's go to the third one, which is your data integrity service. So you know that data integrity actually deals with the accuracy and the trustworthiness of the data. It assures that messages are received as sent by an authorized entity with no duplication done, no insertions, no modification, no reordering, no replay, or even loss of the packet or the packets being damaged. So your integrity service will have to ensure the correctness of the data, the accuracy of the data, the consistency of the data, and also the trustworthiness of the data. So there are 5 specific integrity services. Once again, just like your confidentiality service, the integrity service can be applied to just a single data block or to all the data blocks in a connection-oriented transmission. Let us check out the 5 specific integrity services. The first service is something called as connection integrity with recovery. So provides for the integrity of all user data on a connection and detects any modification, insertion, deletion, or replay of any data within an entire data sequence, and it will try to recover the original data. It will only try, it's only attempted. It might be successful and it might not be successful. So that is what comes with the connection integrity with recovery service. So you are implementing integrity for the entire user data on the stream, and you will have protection against all these things: modification, insertion, deletion attacks, or even replay of the data. And because there is this recovery component added, this service might try to recover the original data. The second specific service under integrity is connection integrity without recovery. So basically, you do everything just like above, only that there is no recovery attempted. We will only provide detection of any kind of attack that has been done on the data, but will not try to recover the original data. The third service, once again, selective field connection integrity. So it provides for the integrity of selected fields within the user data of a data block transferred over a connection, and takes the form of determination of whether the selected fields have been modified, inserted, deleted, or replayed. In simple sense, as I told you, in a particular data block, you might have the header, which has got a lot of fields in it, isn't it? So if I want to provide integrity to these particular fields, not all of them, maybe some of the fields, I can apply this particular service. So which will tell the receiver if any of these fields have been modified or replayed or even deleted or inserted or new thing inserted, it will tell the receiver that such a thing happened, and the receiver will be able to detect that these fields have been modified. So I'm not providing integrity for all the data blocks, for everything, for an entire block. I'm just implementing it for selected fields within the user data. It might be for one data block, or it might be for all of the things. You can see provides this. The next service is connectionless integrity. It provides for the integrity of a single connectionless data block and may take the form of detection of data modification. So here what happens is, for this particular service, it provides the integrity of a single connectionless data block. So rather than implementing it for the entire or for all the user data on a connection service, I'm just implementing it for one data block. So the receiver will be able to identify if there has been any modification or any kind of insertion deletions which have been done on this data block itself, but not on the entire data stream. That comes under the connectionless integrity service. The last specific service that belong to the integrity category is selective field connectionless integrity. So once again, just like the above, but rather than providing integrity for the entire single data block, now I'm going to provide the integrity for only the selected fields within this block. The main difference between this and this is that here all the selective fields are done, or the integrity is provided for the selective fields in all the data blocks, and here it is actually done for the selected fields within a single data block. So these are all the 5 different services that comes under your integrity category. So we completed what? Come on, just give me a thing. So we completed, we spoke about the authentication service, integrity service, and confidentiality service. Let's move on to the next one, which we call it as access control. So access control, the name itself tell you, how do you control the access to your resources? How do you provide the access? It is the ability to limit and control the access to host systems and applications via communication links. So to do so, to implement access control, each entity trying to gain access must first be identified or authenticated so that access rights can be tailored to the individual. What it says is, see, if you want to implement access control, first you have to identify who is trying to access, from where they are trying to access, what they are trying to access. Of course, if they have access rights, what they can do with the data. All of those things comes under the access control part itself. And then we can write the access control rights or access control list, which has been tailored to the individual. There are many types of access control which are not covered here as of now, where we can think of role-based access control, mandatory access control. Some of these are the most common ways of implementing access control within an organization, and discretionary access control. We'll talk about more about these things in a separate video. I want to dedicate one video for access controls. Then I'll try and see if I can discuss more about these controls in that video. So the prevention of unauthorized use of a resource, that is, this service controls who can have access to a resource, under what conditions accesses can occur, and what those accessing the resource are allowed to do. So these are the 3 things: who can access, what they can access, and how much they can access. All those things comes under the category of access control. There are many mechanisms which work under access control. And this is one of the primary things in an organization that has been set up so that the control of the access to your system resources or your information system is regulated. Okay. Now comes the non-repudiation. So this service does not allow the sender or receiver of a message to refuse the claim of not sending or receiving that message. In simple sense, if you implement the non-repudiation service, a sender cannot deny sending a message. A receiver cannot deny receiving a message. As simple as that. So we have two subcomponents here. One of them is non-repudiation origin, which helps the receiver to prove that the message was sent by that particular sender itself, and non-repudiation destination, which helps the sender to prove that the message was delivered to the intended receiver. So it actually tells you that nobody can deny, the sender or the receiver cannot deny that the message has been sent or received. That comes under the non-repudiation service. The last category in security services is availability. Both the X.800 and RFC 4949 defines availability as the property of a system or a resource being accessible and usable upon demand by an authorized system entity according to performance specifications for the system. Simply put, availability tells you that the system or the resource must be available for the authorized entity to use at the time of need. So if I want to use this resource, if I want to use or if I want to access a particular resource at some point of time, it should be readily available. That is what availability service is all about. So there are a lot of attacks that can be done on availability. So a variety of attacks can result in the loss of or even reduction in availability. A common attack that impacts availability is the denial of service attack, DOS, in which the attacker interrupts access to information system devices, or other network resources. So this is what we call as a DOS attack, where you can send thousands of messages. Of course, there is a new version which has come in, which is your DDoS attack, distributed denial of service attack, which makes use of botnets and zombies, where you might get infected, and a command control center, which can send huge messages or huge number of requests at a single instance to a server, thereby breaking down the entire service. So how do you safeguard against availability? You see, when you type in, when you're browsing the web, when you're trying to download something, you come across the captchas or some fill in the blanks, those kind of things. Those are implemented to ensure that differentiation is done between a human and a robot or a bot. If it is a bot, it might not give you the answer. If it is a human being, it can give you the answer. Only after doing the right captcha, after passing that particular test, then you will be allowed to enter or proceed further. So it depends on proper management and control of system resources, and hence is dependent on the access control service and other security services. So if you want to safeguard against availability, you have to implement backups, redundancy, and you have to think about what kind of attacks that can be done. All those things have to be taken care of. Proper management and control of system resources. It is also dependent on other things, just like your access control service, if somebody wants to do like that, and other security services for proper implementation of the availability. So these are the security services. You have to understand these well to proceed further if you are interested in this particular domain. So just let me, if you want to recap, the first service is authentication. The second service is your confidentiality. The third service is integrity. The fourth service is your non-repudiation, availability, and access control. All of these are vital if you want to learn cryptography or even cyber security or even network security for that matter. So with that, we'll stop here. And in the next video, let me make a video on the security mechanisms, and then we will discuss about the model of network security. Till then, take care and good luck. Thank you for watching.